Good day. We're going to go over our test review in regards to writing and factoring polynomials. Now, my suggestions to you is you try each of these problems where you're looking at this video. Now, if you're seeing me work out the problem, I encourage you to write it down. Then afterwards, get a blank sheet of paper and try it again by yourself. So let's go ahead and start with the first one. Now, in regards to the first one, the directions state use synthetic division to find the quotient and the remainder, which means that the first step when you're doing synthetic division is go ahead and rewrite this one with the powers. So this one should be 4x cubed to the fourth minus 0x cubed plus 0x cubed minus 3x squared plus 2x minus 12. And then after that we find our c value. Our c value is found from here when we set that equal to 0. And we say our c is equal to 2. 2 is placed here, and we write the coefficients of our polynomial, which is going to be 4, 0, negative 3, 2, and negative 12. We draw a horizontal line to make sure we leave space. So when we do our synthetic division, we actually come up with, so let's do that, we actually come up with our remainder, quotient and remainders, the two things this is going to produce for us. So first I bring down the leading coefficient, I multiply, so I get 8, add, multiply again, 16, I end up with 13, multiply again, 2 times 13, 26, end up with 28, and lastly 2 times 28 is 56, and 56 plus negative 12 comes out being 44, which means that I got two things. Here's my remainder, and here's my quotient. So you can put down remainder is 44, quotient actually ends up being 4, quotient, let me make sure I spell that right, quotient, actually start spelling it wrong, that's a 0. Let me erase that so I could make sure that I am grammatically correct here. Let me change the actual color there. Quotient. Okay, quotient's going to be, now remember, when we write down the quotient, you see how we started with the power of 4? You're going to start with one power less. X cubed plus 8x squared plus 13x plus 28. And there is my quotient. There's my remainder. Now you could also write it in the quotient form, which means that this would just be plus. Let me show you what I'm talking about. You either write that that's the remainder. There's not really a requirement to this, but in some of the other ones, like when we do in the factor theorem, we will be required to write this down. 44 over x minus 2. That should be the quotient of this whole thing. So here you go. So there is the quotient of that. Now let's go ahead and now do the next one, which is asking for us to do the same thing. So let's go ahead and work through it. Now, if you haven't tried it, pause the video now and try this before I go through my example. I'm going to go ahead and just erase all this just because I want to make sure I got enough space for the other one. And you got to realize that this pen on the smartboard writes a bit large. Now, let's go ahead and now do the next one. Next one, we're going to go ahead and do the same thing, steps, rewrite your powers. X to the 6 plus 3x5 plus 0x4 plus 4x cubed plus 0x squared plus 2x minus 12. C comes out being then negative 2, and the reason being is because you set it as 0. Find out what C is. Okay, with C being 2, or negative 2, let's write this here and rewrite our coefficients. 1, 3, 0, 4, 0, 2, and negative 12. And the negative 12 didn't look so good, so let's fix it. Negative 12. Let's do this line, do that here, and begin to do our math. 1 times negative 2 is negative 2. 1 again, negative 2, negative 2, negative 2 here, 4. I end up with 8, negative 2, 16, 16, goes ahead and gives me negative 32, yes, negative 32, I get negative 30, and negative 2 times negative 30 is 60, so I'll end up getting 48. Now I just want to double check my math real quick, so just give me a second to look at this problem. Make sure I wrote everything out correctly as far as the coefficients, and it looks like I did. And let me see my expressions of coefficients, if that was all done correctly. And it seems like everything looks in line. So in my case, I went ahead and I did get, we do have this, oh, you know what, there is the error. I knew that it didn't seem like something when I had worked it out. There's a negative here, which means that there was a negative here, which states that all this right here needs to be changed. So we're going to get a slightly different result. And let's see what the new result would have been. Because remember, this ends up being 0, 0, 0, 0, 2. And then from there I end up getting negative 4, which produces negative 16. So that's my new remainder. Now, what's my quotient going to look like? Quotient's going to look like this. X, now remember, we're starting with 1 power less. So x to the 5, x to the 4th, negative 2x cubed. I'm going to skip the 0, the x squared, and the x, and just push the 2 down because that's where the spot of it's located. And my remainder, minus 16 over x plus 2. So there you go. Alright, fantastic. Now let's go ahead and move on to the next problem. Next problem says, use synthetic division to determine if x minus 1 is a factor of this polynomial. Again, I could rewrite this polynomial, but in this case, that polynomial is fine. Which means the only thing I do is locate c. c is 1. So let's go ahead and write down c right over here and write down our coefficients of our polynomial and begin our process of synthetic dividing them. Start with the leading coefficient. End up with 2 there. 2 times 2 is 2. End up with negative 8. And 1 times negative 8 is negative 8, which means I get 0. Which means that, yes, it is a factor. And what I mean by is, x minus 1 is a factor. And the reason being, because 0 is a remainder. Anytime you get a remainder of 0, it means we have a factor. Now let's go ahead and do the next one. It says use the factor theorem to determine whether x minus c is a factor. If it is, write f of x as a factor form of f of x minus c. Okay, so this one's saying if it is a factor, you want you to write this. Now again, I look at the polynomials and they all go in order. So we're all good there as far as we don't have to rewrite it. But let me take my c value, which is 2, and now write my coefficients 2, 8, negative 5, and 5. And we'll start synthetically dividing to see what we get. 2 times 2 is 4, 12. 2 times 12 is 24, and we end up getting negative, well actually, yeah, 19. 2 times 19 comes out being 38, and from there 43. Now, it's not a factor, so I'm not going to write it in this x minus c form, because it says if f of x minus c is a factor. It's not a factor. If it makes you feel better, you could write it still in that quotient form. It would just be x plus 2. Actually, not x plus 2, x minus 2. Remember, you're always putting in the opposite value you have there. And that would have been 2x squared plus 12x plus 19. And then you have plus 43 over x minus 2. There you go. All right. Let's go ahead and head over to the next page. Try this one before you see me do the solution. Okay, so you could pause the video, but I'll go ahead and try it now, given that it's assumed that you tried. Now this one is missing an x squared. You notice in the power, so we're going to have also right in here, we're going to have 0x squared to be added on as well. So from here, let's go ahead and now start with our c, negative 3. And our coefficients, 1, negative 2, 0, 15, and negative 90. So let's go ahead and now put this as here, and try our processes. Alright, here you go. Start with 1. Negative 3 times 1 is negative 3. Negative 5. Negative 5, 15. 15. Negative 3 times 15 is negative 45. I get negative 30, and negative 30 times 30 is positive 90, which means I get 0, and it is a factor, so like in this case, f of x will be x plus 3, and again, because opposite of that, and from there we'll get our factor form, x squared plus, well actually not x squared. The mistake I made is that you see how we start with the fourth? Means that in this case, I need to start with not squared, x cubed. So let's do that. X cubed, and change the other one to minus 5x squared plus 15x minus 30. Fantastic. There you go. Now this one wants us to list all possible rational zeros. When it wants you to list, that means we just need to come up with this. Doesn't mean we have to find out which ones work. That's the best part of that. Now, try this. If you don't know where to start, remember, we're going to do P's and Q's as the first step. Now, after that, you find the factors of each one, and we list them. Factors of 5 are just 1 and 5. Factors of 2 is just 1 and 2. P's could be plus or minus 1 and plus or minus 5. Q's could be plus or minus 1 and plus or minus 2. And then we do P divided by Q. Now, please remember, when you do this process, you're taking this dividing with this, and then this without it with there. So which means in this case, we end up with 1 plus or minus 1 and plus or minus 1/2. Now from there, we erase that process. We use the same Q's, but we're going to do the same idea, now following the other front. We divide this with this and this with this, so I end up with 2 additional digits, which is plus or minus 5 and plus or minus 5/2. This is the actual answer. This is the list of all potential zeros. And that's exactly what I'm doing. This potential zeros is that. And you can do the same thing for the next one. So let's go ahead and actually try for the next ones again. P's and Q's. P's and Q's. Remember, P is the last one that's on there. You got to memorize that. Again, assumption is that you've tried this. And assumption is, too, that you're going to try it again after you're done watching. Just make sure you can recreate it. Factors of 9, negative 9. Well, just in this case, it's just the number. So we're going to have, in this case, 1, 9, 3, 3. With 4, I'm going to have 1, 4, and 2, 2. This one's going to be longer because my P's are going to be plus or minus 1, plus or minus 3, plus or minus 9. I have 3 there. And I also have 3 Q's, which is going to be plus or minus 1, plus or minus 2, and plus or minus 4. Remember, we don't list repeats. Now, P divided by Q, we're going to follow the same sequential unit we did over there, as far as the sequence of dividing. Plus or minus 1, plus or minus 3, oh, I'm sorry, plus or minus 1/2. Hold on a second. Let's go ahead and correct that. It's going to be a plus or minus 1/2, plus or minus 1/4, and then plus or minus 1/2 for the first one's already been done. That's a repeat. But I don't have 3/2, and I don't have 9/2. The very last one, and really what I'm doing, for those that just are losing what I'm doing, is I'm taking each one of these Q's and dividing in this order. So like my next one's going to be a 4th. That's a repeat because it's here. So I'm not going to write that one down. I don't have 3/4 on the board, so that's going to be my next one. Plus or minus 3/4. And lastly, my last one is going to be plus or minus 9/4. There you go. We actually have all of them. Oh, actually, you know what? No. No. Everything I just said right now, I got confused with the order. We're not doing it in that manner. We're doing it when I started writing what I'm doing. We're doing each one each of the q's to each one of those. So what does that mean? With all the other previous ones, I was doing this, taking each of the q's and dividing it with the p. So like in this case, let me erase this too. Let's go ahead and correct what we just did. So like in this case, we'll have 9. And you know what? I think these other ones, we have them already, 9 halves. I'm trying to think if how I came up with those. I think we did this whole thing correctly when I was dividing, because I might have followed that same process. Let's see. I have 4th. Okay, these 3 are right. I just checked. I went back. I'm going back to my ones and checking which ones are right. And I did a half, a third, and okay. This is where this one does need to be fixed. Is it? Yeah. This one doesn't need to be fixed as far as sequential. And really what I was doing is I was going back and looking at it, and I was determining, okay, I was right at the 2's. And I said, okay, I have a half. I said, I have 3 halves. That's what I wrote down here. But then I realized, oh, here, there you go again. The same thing. Hold on a second. This is what I was doing. Let me try to fix all this again. Plus or minus, plus or minus. This is what I was doing. And you got to make sure that if you realize that there's something not going right, that we're doing this. And erase all this. Okay, because I went ahead and you have to do this. You got to check your work, just because no matter what you're doing, you could either false slip, kind of like what I did right now, as far as not paying attention all the way. And really what we're doing, I was at this level. I did the first 3 right, but the next ones is the ones I was not doing right. So that's what happens sometimes when you want a shortcut. I'm just trying to say, oh yeah, I know this. Plus or minus 3. The next one, plus or minus 3 halves. And then after the lastly, that one, plus or minus 3/4. So those really should have been my answers in the order that I'm placing them. Now, we'll do our last one. Oops, one that took it a little too far. There we go. Okay. Last one was this one, and where we're going ahead and doing now a 3 with the 9. So we're going to do this, this, and this. So I have plus or minus 9, plus or minus 9 halves, and plus or minus 9/4. So I got all. So now this is the list of all my potentials in the correct order. Now, what did it take for me to do this? It actually, if you notice, I realized I was making a mistake. It took me back of rechecking all my work. But if I check all my work, even if I do now, I could go ahead and identify how I did it all right. Because I could go ahead and re-follow my sequence now. Okay, great. Let's go ahead and move on to the next one. Now, on this next one over here, actually, you know what? I shouldn't erase that. I'll just begin here. It says find all the real zeros of each polynomial function using the real zeros to write each function in factor form. Okay, now what is this going to take? It's going to take for us to do our P's and Q's, like we were doing before. But at the same time, what it's also going to do, we're going to, let's see, this is P, this is Q. So we'll have 8, so factors of 8, 1, 8, 2, 4. That's it. Q's, 1. 1 and 1, which means that the nice thing about this when we have a P and a Q like that is that you got plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Q's are going to be just plus or minus 1. So when I divide my P's and Q's, the nice thing about this is that this one's just going to divide there, 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 and there. And in essence, give me my same list back. Plus or minus 1, plus or minus 2, plus or minus 3, oops, plus or minus 4. Plus or minus 8. Now, let me go ahead. Now, this is when we start doing synthetic division. So we're going to start with the, you always start with 1, and then you move to the different ones. And at times, if you want to graph it and see where it crosses the x-axis, that's also suitable as well. And what I mean is graph it so you can know which of these might work. Let me show you, for example, what I'm talking about. You bring out your graphing calculator, which mine's is pulling up. In the meantime, I'll write the actual coefficients of this once this is actually loading. There we go. Okay, so go ahead and make sure that I'm actually in, well, here, let me make sure I'm in touch mode here. And then I'll go back to the calculator and move it. And so I can see the code polynomial, and let me reset it. Second plus 710. Now I go to y equals, and I type in that polynomial. X raised to the power cube minus x squared minus 10x minus 8. Now if we hit graph, you can see that you have a couple of zeros. You got one at -1 and another one at -2 and another one at 5. So which means that I'm going to skip 1. I'm going to go jump right into -1. So let me go ahead and write that down. Saves me a little time. It says the -1 pi should be a factor. This actually should. Now my coefficients on this synthetic are 1, -1, -10, and -8. So go ahead and factor down 1, -1 times -1, positive 1, 0, 0, -10. Well, let's see, 0, -10, -10, -1 is positive 10, and I end up with 2, which means that it looked like it was going to pass a -1, but actually it did not. That's really what this is saying. Unless I missed something to do with my polynomial, let's check our polynomial again to see we got all the correct coefficients. I do have 1, I do have -1, I do have -10, I do have -8. And I check the processes on this. 1, -1. There's my mistake right there. It is. And so this is why you should always check your work, because you can find out where is it that you may not have everything in the right manner. So here we go. -2. -2 times -1 is now positive 2. And positive 2 is -8. Let's say this, right? Yeah. So then -1 times -8 is positive 8, and I end up with the remainder of 0. So, which means that now I know I got x minus 1, x plus 1 as a factor. That's one of my real zeros. And I also have this, x squared minus 2x minus 8. And this could be factorable, I think. So if I think about two numbers that add to give me -8, I mean multiply give me -8, but add up to -2. Yeah, we do have one. We have -4 and positive 2. Which means that another two zeros that I have once I factor this out, so x plus 1, x minus 4, and x plus 2. And that should be my factor form. What did I do? Once you got it down to 3 terms, which we did, put it in this form, and then afterwards get the actual factor formula, which is there and there. If it doesn't look nice, you always could use the quadratic formula for that as well. Okay, now I am running a little bit out of time, so I'm going to go ahead and jump. This one's going to follow the same steps as the last one, but I'm going to go ahead and do these other ones, and then if I have time, I'll go back to 9. But let's go ahead and find the remaining zeros of this complex polynomials whose coefficients are the real numbers. So it wants us to find the remaining zeros. But the nice thing about this is that one theorem we have where it says conjugates. So any imaginary number has a conjugate. -3i is the other remaining zero. And after that, this one has 2 minus 4i. So that's good. And I think that's all they want us to do. Find the remaining zeros, complex number whose polynomials are the real numbers. So there you go. Complex functions. Oh, whose coefficients are real numbers. Okay, so this is what's going to take from here. Once you have this, what do? You go ahead and actually make, it wants a polynomial whose coefficients are real numbers. Currently right now, we have a polynomial whose coefficients are not real numbers. We have a polynomial that is, if I wrote it down, I'll get x plus 1, x minus 5, x plus 3i, x minus 3i, x minus 2 plus 4i, and x plus or minus 2 minus 4i. So, what do we have here? We have this big polynomial. What is your duty to do? Is to actually go ahead and FOIL it all out. Now, I will tell you that on this part right here, on this section right here, oh, let me go ahead and actually change the color of that. On this section right here, okay, it's probably best to use the shortcut method. And what is the shortcut method? You square the variable, minus 2ax plus a squared plus b squared. All you have to identify is a and b. In our case, this is a plus bi, which states that a is 2, b is 4. And you can substitute that in. These other two right here, you can go ahead and actually FOIL that. I don't want to use red again. You can FOIL this, and you can go ahead and FOIL this last one as well, and then make sure you FOIL it all the way through. So that's what you do for that one, and then for this one, let's see. And you're going to do the same thing for question 11. Now let's look at question 12. Question 12 says, form a polynomial f of x given with the given zeros. You must multiply each of the factors back together when given your solution. So now with this one right here, whose coefficients are real numbers, find the remaining zeros. Okay, actually, you know, with this one I read too much into the question, but this one all you really had to do is just this part right here, which is this section right here. You came up with the remaining zeros. Like with this one over here, this will be easy to solve because the remaining zeros on this one is only negative 3 plus 2i. And those are done. This whole thing that I did over here is actually probably more related to this one because it wants you to form a polynomial given the zeros, which means that you do need, in this case, you do need to find the remaining zeros, and then afterwards write it all out in our factor form, which in this case was x plus 1, x minus 2, x plus or minus 3. Oh, no. This is going to be x minus, but that 3 actually has the imaginary numbers to it. So we're going to have this with it. X minus 3 plus I, and x minus 3 minus I. Okay. It's this section right here that I was talking about. You want to use the shortcut method. So now try this yourself. See if you remember the shortcut method. So you may want to pause the video. Now if you find that it's not something that's working out for you, then turn on the video again and see my steps. Now first of all, I'm going to go ahead and make sure I identify A and B. A is 3, B is 1. There's a 1 in there. Now, go ahead and write in here x squared plus 2. Now I'm going to write in 3 because it should be ax, well not plus, minus 3x plus a squared, so 3 squared, plus b squared, 1 squared, which means I get x squared, and there I go with that, trying to make a plus symbol. I really want to make sure I got minus 6x plus 9 plus 1. So in this case, I'll go ahead and actually get on this side, x squared minus 6x plus 10 on, and then the only thing I need to do here is follow this. So I'll get x squared. Actually, I probably want to stop just one unit above, because I do need to do some simplification. I want it to be at the same level as that. Minus 2x plus x minus 2. Then in parentheses. These two combine, it gives me x squared minus x minus 2. And now all you need to do is just FOIL these two trinomials. So with that, all you need to really do is start FOILing. And you should end up with x to the fourth minus 6x cubed plus 10x squared. And then you start doing with the next one. Minus x cubed plus 6x squared minus 10x. And lastly, with this one, so minus 2x squared plus, and write them this way, plus 12x minus 20. Okay, start identifying like terms. Alright, so x4 is the only big one. I do have 2x cubes. And I'm going to be changing colors because I just want to make sure I don't get confused, and pattern shapes. Okay, so I got 3x squared, and then as far as x's, I got 2 x's. I want to box these. And then numbers, actually I only have one number, so which means that when I add all these together, my answer would be x to the fourth minus 7x cubed. Okay, I got this 10, 16, and, hold on, yes, 10, 16, and then 14, so I get plus 14x squared. And then my x's are the two box ones, so I end up with 2x minus 20. And there's my polynomial. They got form from everything that I just did. Okay, great. Alright, so go ahead, practice these. I highly suggest that if you had difficulty with any of them, practice them again. Like, go ahead and just try it without looking at it and you trying to recreate the magic that's been shown to you. I thank you.